Hello friends, welcome to Science with me. My name is Dr. Erica with Rosie Research and we are doing an amazing Mario unit. If you love programming, make sure you check out our Scratch programming of a Mario video game playlist. It's 8 videos long and you will get a lot of really cool stuff done and it'll be a lot of fun. We are doing some hands-on projects right now, and today we're going to learn a little bit about the difference between 8-bit characters and 32-bit characters and what that means for how they look. And we're also going to look at how do we put colors into binary, because binary is a series of zeros and ones, and how do you talk about colors with just zeros and ones? And it turns out that we actually use 8 bits, so 8 zeros or ones to talk about red, which gives us 256 levels of red, basically from white all the way to red so dark that it's basically it's really, really dark, right? It's like the darkest red. And then you have 8 bits for green, so you have 256 levels of green and 256 levels of blue. So you take all those 24 bits of information and you can get millions and millions and millions of colors out. Now, I don't know about you, but I don't think it'd be very fun if you were trying to color something in and you were like 10011000110, and you had to pick out the right color pencil for that. So today we only have 4 colors, and to encode 4 colors into binary, you need 4 different things, and we can do that with 2 bits. So 2 zeros and 2 ones total. So you have 00, 01, 10, or 11. And so our 00 is going to be white, just like if we had all zeros in our red, green, blue, that would be white. Our 11 is going to be black. So if we had all ones for all of our reds and greens and blue bits, that would be black. And then we're going to go 01, which is sort of a lightish tan, and then a 10, which is a darker tan. So that's how we do colors in binary. And we have this great little handout that gives you what color to do it. So it's color by number, but it's not quite because it's color by binary. So I'm going to take my pencil, and every time I see a 0 or a 1, I'm going to go for this light tan. And you can just sort of go around and look for them, and we will see what little character we get here. It's totally okay if you mess up. And there's a spot for you to make your own, which is a lot of fun. And if you make your own and you send it to me, I will happily color it in. Just send me like a picture of it. I could print it out. It's always fun to see your guys' projects and what you guys are working on. All right, and just like when we did our Mars unit, if you haven't checked it out, we have a Mars unit, and we actually look at the very first picture of Mars that ever came back. And we color it by number, the same way we're coloring this by number. And we get that picture. It's the same way that the scientists at NASA's JPL did it. It's really fun. You can get that printout over at patreon.com/Rosie Research if you check out our Mars unit. So this is like stuff that happens in real life, but we also talked about then, and then we'll talk about it now, is like, how does resolution change what you see? So resolution is sort of like, how clear is your lines? How crisp are they? In real life, we kind of have like basically infinite resolution. Our resolution is the rods and the cones in our eyeballs. So it's a cellular size. Right, we can't split our rods and cones and see a rod as half and half. We see it all as one color. So that's sort of our resolution. But here we have this resolution that's like sort of a 1 centimeter square thing. And what does that mean for how this object looks? And you can see that it looks pretty blocky. You don't have a lot of detail. And what we can do after is we can actually look at the detail between this and 32-bit resolution. So 8-bit resolution it's an 8 by 8, so there's 8 boxes by 8 boxes. And that's what we are looking at right now. 32-bit resolution is 32 boxes by 32 boxes. So I've split all of these boxes into a lot of other little boxes. And so then you can see things better. So this is what, oops, I actually messed up. I have 0 zeros here. This is what my little guy looks like here. You can kind of see that it's maybe something, not quite sure. But if you want to see it a little bit better, oh, I see 2 more I have to color in. You can also color in our 32-bit. And I will do that. We'll speed it up though, so you don't have to watch me the whole time. But here's what our 32-bit looks like. and think in your head, you can pause the video, what will change in the image? If there's the same data behind these two images, behind this one and this one, what does the smaller squares help me do? What does it help me see? And what does that mean for the way my brain perceives it? Does it look clunky like this, or does it look more refined like real life? We'll find out. And this will be a lot of fun coloring it in. Here we go. Alright, so we finished this amazing, cute little high-resolution Goomba. If you did our Scratch programming projects, you might recognize it wearing one of its walking costumes, because this was a Goomba that we decided we would jump on and kill. And if you look at the two, you'll notice that the high resolution, I have a lot more detail. I have these eyebrows now, I have pupils of my eyes, I even have the parts around the eyes. Here I sort of had eyes, and the parts around the eyes, and its little mushroom, the stem body sort of all went together. I have a lot more in terms of sort of the way it comes down is really much more smooth, and the shoes look way cuter. Right here it's like you're not actually sure that this one would be a shoe, and that's the difference between resolution. As we go up in resolution, these things get better. The sort of diagonal line gets better. You don't have quite as much step, and when you go further away you can see it really, really well. Thank you so much for joining us as we looked at 8-bit to 32-bit resolution, how it changes the images, and also a little bit about how we digitize colors and how we can take colors and put them into binary, which is all zeros and ones. I hope that we will see you soon, and have a great day. Bye, friends.